What's being shown now with chiral-induced spin selectivity is that you have to have had near perfect chirality at the start of life. It's not something that you could have evolved into. Dave in his video likes to just say, oh, he just blows it off. He says, this is something esoteric that Tour talks about. No, just because you can't answer it doesn't mean that it's esoteric. It is a real thing.
Hi, I'm Steve Meyer from Discovery Institute Center for Science and Culture, and we have taken a particular interest in this spirited exchange that's been taking place on the internet between Dave Farina, also dubbed Professor Dave, and Professor James Tour of Rice University. Dr. Tour is one of the most distinguished scientists in the world, rated one of the top 50 scientists in the world. He has 600 peer-reviewed publications or more, and 150 some odd patents. He's a specialist in organic synthesis and nanotechnology.
So 1, 2, 3, 4, 5 carbons.
Professor Dave is an internet blogger who has a tremendous following online and has brought to the attention of many the controversy over the origin of life and what's called evolutionary abiogenesis.
Hey everyone, it's been quite some time since my two-part series demolishing every last one of James Tour's ridiculous talking points.
He's been a staunch critic of Dr. Tour and some of Dr. Tour's videos, and I wanted to just start, Jim, by asking you about this controversy, why you decided to weigh in the first place. Some might have seen it as a bit of a mismatch between a person of your eminence and an internet blogger. Why did you decide that this issue needed to be engaged in the way you've engaged it?
Well, I have nothing in particular against Dave Farina. I was just minding my own business, giving my own talks, and he came out with a video called Elucidating the Agenda of James Tour, as if I had some agenda behind speaking on abiogenesis. And my work is always just trying to expose the current work in abiogenesis and origin of life research, and I think do the work that reviewers should have done when those papers first came out, because I felt that actually that work screamed out that this could not be how life actually formed. And so when he came out with this video, every slide that he showed in the video was wrong. Every slide was wrong, and he has many viewers, and I thought, well, it'd be good to straighten this out, and so I came out with a 13-part series on abiogenesis, but I had to go through a lot of the background chemistry, and in doing that, I never called Dave Farina stupid. He says I called him stupid over and over again. I never called him stupid once. I never did. And I just talked about the science that was there, and I said that Dave was wrong. He was wrong on every point that he had made on that series. And so I just pointed that out.
Oh, yeah, sorry to interrupt. So you had a series of, I think, from what we've seen, very informative videos about the problems facing attempts to explain the origin of life from simpler non-living chemicals. And maybe we should actually start there just for our listeners and viewers. There are two branches of evolutionary theory. There's the chemical evolutionary theory, which attempts to explain how you get the first living cell from simpler non-living chemicals. And then there's biological evolution, which attempts to explain how you get new forms of life from simpler pre-existing forms. Your videos addressed only that first issue, the origin of the first life from simpler chemicals. And so anyway, you put that series out, and then Dave Farina came back with some more videos challenging you, but this time he cited a lot of experts in origin of life research, origin of life biochemistry, and I think that's given you a little bit more of an opening, I think, to have a scientific discussion at a high scientific level. I think you were probably not wanting to have to engage an internet blogger on these things, but due to the misinformation, I think you felt you had to. But now you're able to address some of the leading figures in the field, because those are the people he cited in his critique of you. Is that where we are in the discussion?
Right. So the good thing that Dave did is he brought on 3 experts to address the chemistry that I had talked about in my videos, and those 3 experts. And then he brought on 3, and then he cited several others, and so that's good, because now I can engage, particularly with those 3 that were presumably addressing my video. and I could go right after their science and talk about that.
Oh, and that's what we want to talk about. And I think, just again, as another preliminary, I would say that another good thing that Professor Dave has done in citing these experts in critique of your work is that I think it enables his viewers and our viewers to really assess the standing of these arguments that are being made in support of evolutionary abiogenesis. I had a supervisor in Cambridge when I was doing my PhD on origin of life biology, and he used to say, beware the sound of one hand clapping. If there's an argument on one side, there's bound to be an argument on the other. And you really can't assess, he said, the strength of an argument until you see how well it withstands criticism. And I think that applies to the to your critique of evolutionary abiogenesis, but also Professor Dave's critique and the experts he cites critique of yours. So we have the arguments out there, and let's revisit them, and let's let our viewers hear your side of the story, and then people can begin to evaluate this for themselves as both sides of the story are increasingly out in public.
Abiogenesis is the origin of life from non-living matter. And to construct any convincing theory of abiogenesis, we must take into account the condition of the Earth about 4 billion years ago. These are not my definition. These are textbook dictionary definitions. All right?
You've given a lecture, and it's a very detailed lecture with a lot of science in it. And the expert on the other side of the question that you critique and cite is a man named Steve Benner. So we're going to get into some of his work and his claims. But maybe we could start with just a basic definition of life. I mean, because my supervisor used to say that behind every question about the origin of life lies another question, which is, what is it that we're trying to explain the origin of? Or as Alexander Oparin used to put it, one of the early chemical evolutionary theorists, the question of the origin of life and the nature of life are inextricably linked. We can't come up with a good origin of life theory unless we know what we're shooting for, what life is. So how do origin of life researchers and how do molecular biologists or cell biologists define life today?
Well, I think that defining life, as you know, as a philosopher, is hard. Defining the characteristics of life is actually a much easier thing to do. And we know that all life as we know it is made out of cells, and you have a membrane on the outside, and you have DNA inside, and you have a lot of machinery going on in there, and you have to have 4 classes of chemicals. You have to have the amino acids, which are the building blocks of the proteins. You have to have carbohydrates or sugars, which are the building blocks of the polycarbohydrates or the polysaccharides. You have to have the lipids, which are the membrane, and then you have to have the nucleic acids, which are the DNA and the RNA. So you have to have those four classes of chemicals, and then you have to have a functioning system that has something called homeostasis, where there's this internal functioning and operation of the system. It is not just throwing a bunch of molecules inside a lipid. It is a whole functioning together. It is a system. It is a factory in a sense. These are the characteristics of life as we know it. And what some people are trying to do is they have said for years that they'll address this and they'll make this happen, and they've not been able to get close. So now they're trying to redefine what life is. Even the same people that have defined it the very same way that I have, these characteristics, are trying to now change the argument, which is, as you know, is a typical philosophical approach to do that.
Yeah. So they attempt to define life down to some simpler essence or some simpler combination of molecules and say, well, that's all we really need to explain. But the fact is that life with the characteristics that you described exists on this planet. And if we want to even get the biological evolution going, we've got to start with at least a functioning cell. So, and those cells have membranes, they have carbohydrates, they have proteins, they have nucleic acids, and they have intricate interactions. We've got an information storage transmission and processing system inside the cell. So that's what exists. We have to get to that point if we're really going to provide an explanation. I think that's been a great point that you've made. So let's discuss some of the general problems that origin of life simulation experiments have encountered as they've attempted to simulate the origin of those four classes of molecules. You have noticed that there's an awful lot of what's called in the field investigator interference. Can you describe some of the problems that have been encountered under that heading?
Well, certainly investigator interference means that investigators are doing all the work. And even with all the investigators doing all the work, with very intricate work, they have not been able to make any of the four classes of chemicals that are needed for life. Nobody has made the chiral lipids, the lipids that are needed where you have made the two enantiotopic hydroxyl groups of glycerol you've been able to distinguish those two enantiotopic groups. Nobody's ever been able to control any of the stereocenters there. Anything that anyone has made is not homochiral, and even what they've made is with, talking about interference, is with this deep hands-on chemistry using many, many steps that is very hard for nature to use. And their syntheses are all cheated. They cheat at every step of their synthesis, meaning they'll mix A and B, they'll get a series of compounds. They only want one in that series, and they'll identify a little bit of it, a very small amount, in a machine, in an HPLC. But they won't take that and carry it on because it's too messy. It cannot be used. So they'll buy that fresh material from a manufacturer that isolates that from cellular sources, from something that has had life already, and then they'll take that on to the next step, and they repeat that over and over again. So every
and
step
Jim,
is cheating.
Is that to prevent what are known as interfering cross reactions then in prebiotic synthesis? So you have a couple of reagents, you combine them, and then you get lots of byproducts. And if you and maybe one of them is something you want, but if you allow that to continue to react with all the other things that have been produced, you're going to end up with a sludge, or I think one of the products was called melanoidin in one of those reactions I remember studying. So you have to purify and remove those other byproducts, or else you just go and buy the one you want and start the next stage of the reaction all over again. Is that kind of what goes on? And
that's exactly what goes on. They put upon early Earth constraints that they themselves cannot even deal with. And with all their instruments, they will make it in such a mess that they themselves cannot even isolate it. But they leave this to early Earth. That's early Earth's problem, not my problem, they will say. Mm-hmm. They won't say that, but they'll infer that, and then they'll move on. So every step is a cheat. Every step screams out that this cannot be the way that early Earth did this synthesis. Cannot. Even with all their work, they have never made homochiral material.
Well, yeah, and let's talk about homochiral. What does that mean? I remember from chemistry, you've got amino acids come in left-handed and right-handed forms, and sugars come in left-handed and right-handed forms. Are all the four basic types of chemicals that are necessary for life, are they all chiral in the sense that they have two different types of forms or more?
Yes, every one of them. There's a couple of amino acids that don't have stereogenic centers, but everything else has a stereocenter. Actually, there's an amino acid that doesn't have it, but everything else, all classes of compounds have this. All amino acids, save one, all the carbohydrates, all the nucleotides have multiple stereocenters, not just one. And then the lipids have multiple stereocenters, and they've never controlled any of those in any synthesis that's prebiotically relevant.
Meaning go ahead. I was going to say, what does that mean practically? Why do they need to be controlled? What's the
prebiotic relevance means that I cannot use these very sophisticated protection group schemes and catalysts that I've designed over a period of 150 years in modern chemistry, particularly in the last 50 years. We can control stereocenters now. We can do that sort of thing. We can separate these sorts of mixtures using our very sophisticated instruments. But when we say early Earth would never have that advantage, then we have to use only the chemistry that would be available on a prebiotic prebiotic earth. In other words, we're not using any of the sophisticated chiral-inducing agents that we have available to us today in our modern laboratory. That's what I mean, that a synthesis that has prebiotic relevance. They haven't even made ribose. If you can't make ribose, you can't make any of the new...
form of sugar, right?
It's a form of sugar. You can't make any of the RNA or the DNA. You're done. You're toast. That's it. And so what everybody starts with, they buy ribose. And the syntheses that they have of ribose, they don't even use themselves. If you use very, very sophisticated hands-on chemistry, like what John Sutherland has done, you can make ribose, but it is not homochiral, meaning that you have both mirror images of it.
And why is that a problem? Why is if you have both mirror images of the sugar or of the amino acids or any of the other fundamental molecules, why is it a problem to have both mirror image versions of those molecules?
Right. So if you don't have just the one mirror image rather than both of them, you cannot do the assemblies that you need to do to make the life type forms that you're going to need. And this is actually more recent work that's just come out in the last few years, work by Ron Naumann and some of his associates at the Weizmann Institute, that many people said, well, you had stereo mixtures, you had the R and the S, you had the left-handed, the right-handed, and then over time it evolved and it purified. Cannot be. And what he has shown, there's something called chiral-induced spin selectivity, meaning that if you didn't have this from the beginning, you could never have gotten this chemistry to work, because these act as what are called spin valves. The electrons have to go down particular chiral environments, and when you have the mixture of isomers, it cannot work. So you have to have had the chirality at the start. It's not something that could have been evolved into.
Mm-hmm. So you can't form a protein with a mixture of left and right-handed amino acids. You have to have exclusively left-handed amino acids, and there's an underlying physical reason for that is necessary to forming a functioning protein.
That is correct, because these proteins, as you know, are catalysts. These are the enzymes or the nature's catalysts for designing experiments. What we thought is that all of this was just affected by the structure, so that it would influence how something came into it, how a substrate came into a cavity. What we've learned now is that there are electron transfers, and those electron transfers have to go down the prescribed chiral environment. So you could not have had this without having controlled that stereochemistry to begin with. The constraints get more difficult every year, because we're learning more about the cell and the chemistry involved in the cell. So the constraints become harder. So the task...
And what's necessary to provide function, then, for all of these molecules.
Yes, and so the origin of life researcher is for any step forward that they think that they have made. They haven't made a single step forward. For every step forward they think they've made, there are many steps back every year as we understand more about the chemistry that is going to be needed for a living cell. And this nonsense, Steve, that people say, well, cells were much simpler back then. No, this has already been computed by biophysicists, how simple a cell could be. What is the machinery?
Very important work on minimal complexity that's right. Established that minimally complex cell is awfully complex in ways that are quantifiable. I remember your comments remind me, Jim, of my last year doing PhD work on origin of life biology, and my supervisor had just come back from the ISOL conference, and she said, unfortunately our field is becoming populated by cranks. Everyone in the field knows that everybody else's hypothesis doesn't work, but they're unwilling to admit it about their own. That was 1990, and things have only gotten much worse in the ensuing 30-some years. So I feel your pain. But in general, I think what you're saying is that these simulation experiments, they don't take sometimes the experimenters claim they're taking a hands-off approach, but they're actually taking a very hands-on approach at every step along the way. So in order to move the chemistry in a life-relevant direction, there has to be repeated interventions by intelligent agents to restrict the degrees of chemical freedom to move things along in a direction that's going to be relevant to the actual origin of life. Is that the general problem with these interventions?
Yes, that's the problem. For example, if you take Steve Benner's work, where he says he always uses a hands-off approach. First of all, when he has his hands-off approach, he gets billions of compounds mixed together. He will never use it. He will go on to the next step, having bought totally pure material, homochiral material. He will buy from a manufacturer that's isolated this from a cellular source. And so he cheats at every step. And then when he has to have hands-on chemistry, he relies on the hands-on chemistry of others. And so it's just a big cheat all along the way. And I've told him this to his face. I mean, this is what we're dealing with here. And there's
in your little video that we'll embed in this video or link to it of your lecture to the student group at Rice, you show an interesting scientific figure. Is it an NMR scan with lots of different peaks? What does that show? Is that making the point you're making now, that when you do these simple reactions, you get not just the thing you want, you get a whole bunch of things, as indicated by this NMR scan. Is that right?
And it's totally useless. And he is able to identify ribose in that mixture, and so he claims ribose, and he goes on to the next step, having bought ribose.
Why doesn't he just let it go forward naturally then, with all the compounds? They're going to interact? Is that
they're going to interact? Yeah.
You won't get what you want if you let that interaction take place.
Not at all. Not at all. And he knows that. He knows that, and
so he's a very smart chemist. That's why he circumvents the problem by buying the ribose off the shelf for the next phase. Is that
yes, absolutely. Yeah. And this is Dave Farina's expert. So Dave Farina brings us on, and in many ways, Steve, Dave Farina is the victim. He is a victim of what these guys are putting out there. All of this goes back to the origin of life researchers themselves. It is not the press, it is the origin of life researchers themselves. They get on this YouTube channel and they talk about what they've got. Dave Farina buys into it because he cannot read the actual paper and make sense out of it. He doesn't know how to read the paper and make sense out of it, so he's deceived by this. And this happens to many people. It's not just Dave Farina. The thing about Dave Farina is he's got a big audience. And so all I'm doing is I'm not coming against his audience at all. And in many ways, I'm saying, poor Dave Farina. He's the victim. He buys into this so that when Benner says he's done hands-off chemistry and he's got these long nucleic acids, he's got this RNA that he said he has made, Dave can't assess this. He bought the precursors in highly pure form. He never made these precursors. No way. He says he made them. He never did. And then what he actually made, he never made RNA. It had both the 3-5 linkage and the 2-5, which means that it was hooked up the wrong way over and over again. And it even had branching. None of this could be usable. None of this. Steve Benner knows it. Steve knows it, but Dave Farina doesn't. And Dave Farina buys into this. The poor guy is a victim.
So the origin of life researchers overhype this stuff to the press and to others, and then people pick this up and then spread the hype, and then you come along and critique the overhyping of these things, and then you're the bad guy, right?
I'm the bad guy for
get criticized
for exposing this. I mean, even what Steve Benner did is when he says some things in his paper that are way overhyped, and then when he goes to the press, he says, and now we have a consistent model for how you can get Darwinian evolution. I mean, to go from the junk that he made, he didn't even make ribose. But then when he bought ribose, then he brought it on the next step, quoting hands-on chemistry, he didn't even use that. He ended up buying the entire nucleotides that have a triphosphate on there that are ready and preloaded to polymerize. That's what he bought. And then these were isolated from cellular sources, from something that was already living. He bought that, and then he got these things to string together, but in a way that could never work because the zipper wasn't zipped together right. He had the wrong connections here. And then he goes on to make these extrapolations and say that this is even shows how you can get Darwinian evolution. It's a bunch of nonsense. It's such nonsense that even Jack Szostak, who himself can hype a lot of things, said that Benner has gone with the hype rather than with the science. It's not just me saying this now. And Jack Szostak is one of the other experts that Dave Farina refers to. He doesn't even realize that Jack Szostak is contradicting the work that Dave's other expert, Benner, is doing. So Dave doesn't even have the perception to understand that his own experts are not agreeing with each other. In many ways, as they critique each other, they agree with me.
So yeah, that's very interesting. It just is a dynamic in the discussion here. Can we go back a little bit because I know what Benner is trying to do is to produce an RNA molecule, and the reason that RNA is so important now is that there's been this chicken and egg problem that's been involved in origin of life research forever. The realization that you need information, which is stored today in a DNA molecule, to produce proteins, but you need proteins to process and express the information on the DNA. So you have this chicken and egg, which came first. And in the 1980s, it was thought that, well, maybe the RNA could help us solve the chicken and egg problem because RNA stores information, but it also catalyzes at least a few of the kinds of a few of the reactions that some protein molecules will catalyze. So maybe RNA could be the holy grail, the information storage molecule, and also at least some kind of a catalyst that would be analogous to what proteins do in modern cells. And so the idea was that we'd get RNA that could self-replicate, copy itself, have variations on that RNA. That's the reference to the Darwinian evolution getting going on a molecular level, and then we'd be off to the evolutionary races. So if we could just build RNA, we'd be in good shape. I think that was the sort of the background to all of this. And so Benner has weighed in and said, hey, I can do that. I can show, not with hands-on chemistry, I can show hands-off chemistry how to build RNA. And as I recall, there's three main parts in the RNA. There's the sugars, the phosphates, and the bases, just like in DNA. But you're saying he can't even get the sugars, let alone the bases hooked up in the right way. So tell us just a bit more about that now that I've given a little background.
So yes, you have to have the sugar, you have to have the ribose, and then you have to have the nucleobase. The nucleobases actually are pretty simple structures, and those can be gotten fairly simply. But now putting those on the ribose is not easy. And then hooking on a triphosphate is not easy. Very difficult chemistry to do this. Very hard to do this by hands-off chemistry. Even with hands-on chemistry, it's hard. But by hands-off, by what Benner says, he never did it. He says he does it with hands-off. He never did. He bought it. Why did he buy it? Because his hands-off chemistry doesn't work. It just doesn't work. And I'm the bad guy for saying
pointing
this.
that out. You are a bad guy, Jim.
And poor Dave Farina is the victim here. I mean, he's really the victim.
Is part of the reason, Jim, that it's so hard to get these molecules to produce life-relevant compounds is that there's so many ways to hook them up that there's more ways to go wrong than there are ways to go right. Is that the essential problem?
Yes, that is the problem because with the nucleotides you can have both the 3,5 linkage, which is what you want, but you can also have the 2,5 linkage, and that 2,5 linkage throws you off. In fact, the 2,5 linkage can act
off at an angle or something.
It's not the right orientation. Plus, it acts as something called siRNA, meaning small interfering RNA. It interferes with the whole translation process. So the thing shuts down because it forms these duplexes which are too sticky. So when you get the wrong attachment there, and you see this sort of thing. In fact, I got Dave Farina to come around and to, in his second video, and to confess that yes, you cannot get polycarbohydrates, you cannot get these polysaccharides unless you have enzymes. He says, I knew that all the time. That's what I meant in my first video. No, that's not what he said in his first video.
Stop press. That's a very important concession because enzymes in modern cells are built, they are proteins, and they are built with the information that's stored on DNA and transferred to RNA and through the ribosome and the whole protein synthesis process. So if you're relying in prebiotic chemistry on something that's only built by proteins, you're presupposing the existence of genetic information, the origin of which you have not explained.
Exactly. The origin of the information he doesn't even know. But he said that you can get these carbohydrates just keep hooking on to the end there. And then when I pointed out to him that there's all these different tentacles, these ways that you can do it, then he comes around in his next video, he says, yeah, but what I meant was that you couldn't do it until you first have enzymes. But what do you mean enzymes? Where did the enzymes get the information to hook these things together in the way that you want?
And if I may interrupt again,
Yes.
because this is even more, the more you talk about this, the more I realize how appalling these claims are, because the whole point of the RNA world was to build a self-replicating information storage molecule that could also function as a catalyst without enzymes and without DNA. So that we were going to circumvent the whole chicken and DNA protein chicken and egg problem by proposing an original synthesis of information-rich RNA molecules that could copy themselves and produce variants and get the evolutionary process going. But if you have to invoke enzymes to make the RNA world plausible, you have defeated the whole approach.
Well, in deference to Dave, he doesn't suggest that you need enzymes to make the RNA. He said you need enzymes to make the polycarbohydrates. But the same problem happens with RNA. You get the wrong type of attachment. If he's going to concede that you cannot make polycarbohydrates because there's too much variability in the coupling, if he's now conceded to that, which he did in his second series, in his second set of videos, if he concedes to that, why doesn't he have to concede to it with RNA as well? Because RNA can link by the 3'5" versus the 2'5". So if you're going to concede on the one, you have to concede on the other.
Because
you have the same problem.
The need for specificity in all these biopolymers is ubiquitous. It's everywhere.
Exactly.
Yeah.
Any of the biopolymers, you have this need for specificity. You have to have the specificity. You can couple in these different ways. And if you're going to concede that you're going to have enzymes to make the polycarbohydrates, which Dave has conceded to, then why don't you have to have it also to make the polypeptides? Because the polypeptides, half of them have active side chains that if you don't watch those end up participating, and then you get things that are not your proteins anymore, because you can get these opposite ways of attaching. Mm-hmm. That's the problem. You get these opposite ways of attaching. So if he's going to concede on the sugars, he has to concede on the RNA. If he has to concede on the RNA, he's going to have to concede on the peptides as well. But the poor man does not realize it. He's a victim because he believes what these guys say, and he's unable to read the papers to see what they really say. He's unable to discern them. And then he concedes with the carbohydrates, but he won't concede on anything else. But it's the same problem, the specificity problem.
The specificity problem. So let's go back to Benner's claim then, who is a serious scientist. He's trying to make RNA. But in the first instance, as I understand it, he's just trying to get a stable RNA molecule. He's not worried about getting the nucleobases in the right sequence so that you actually would get self-replication, because there's an information requirement for that. He's just dealing with the more primary problem of building the parts and getting them to link together in some stable configuration that would represent an RNA molecule. Is that right? And what are the problems associated with just those steps, if I'm understanding it properly?
Well, he hasn't made RNA. First of all, he didn't make the ribose that you need for the RNA. He didn't make the nucleotide that you need. He didn't put on the triphosphate that you need. He bought it. All right, so that's the first problem. Early Earth...
He bought all of those constituent parts.
All put together. He bought all those constituent parts all put together in one piece. He bought it that way. And poor Early Earth, I don't know where Early Earth is going to buy this from. And then what he did is he allowed these things to polymerize, but they polymerized with no specificity. So not only did he not have the order, he had the 3'5" linkage and the 2'5", and he didn't even tell us how much of the 2'5". He just said it had a significant fraction of 3'5", which is what you want. What does significant fraction mean? Does it mean 2/3? Does it mean 9/10? Does it mean 1/3? He didn't tell us. Why wouldn't he tell us? Probably because it wasn't very good, because many people have made this random polymerization to make what could be RNA, and they come out and they tell you they've characterized it, and it's 70% of the wrong linkage or 30% of the wrong linkage. Let's give him on that low number. Let's say he only has 30% of the wrong linkage. So he has 60%, 66%, two-thirds of the right linkage. What
Is
does
it a
that
moot?
mean?
Is it a moot point either way, Jim?
It's a moot point either way because you need three bases have to be aligned in order to define what one amino acid is going to be. He can't even define one, not even a single one. And the other problem is, as you know, you can't just make one RNA and say, hey, I have this one RNA, and it just happens to be the right order to start building some amazing enzymes. And then you say it copies itself. RNA has never been shown to copy itself. The most it's ever shown in primed systems that were designed to copy themselves, not more than 10% has been
10%
copied.
is the
and that
upper limit.
10%
Yep.
is too short to make any copies
But even
of it.
there, that 10% is only will only ensue if there's a very specific arrangement of the nucleobases on the RNA molecule. In other words, there's a prior information requirement to get even that limited degree of self-replication.
Yes, it's primed to do this. Now, let's think about the stability of one RNA molecule, because even Joshua Swamizas says all you need is one molecule of RNA. How long will that one molecule of RNA last? Well, if there's magnesium chloride, it doesn't last long at all. So they want magnesium chloride when they want to do synthesis, but magnesium chloride will destroy RNA very, very quickly. It'll cleave because of this. So let's say there's no magnesium chloride in there. How long will that last? If the half-life of, say, 600 mer of RNA, that will prescribe for just a 200 mer on a protein. Just the half-life of that 600 mer. Let's just say the half-life is a year. Well, how long will that molecule last? That molecule wouldn't even last more than a couple of days. Under the best of conditions, just by the normal hydrolysis rates. When you have one molecule, you don't have enough to last you because these things are going to cleave. It's the only reason we can work with RNA is because we make billions and billions of them at a time. We deal on Avogadro's number type systems, but when you only have one, its half-life, how long it's going to be retained will be not more than a day or two. That's it. It's going to cleave. So it's toast. It's over. Everything. Steve, this is frustrating to me. I hope you can feel my pain because at every step, nothing works. Nothing works at every step that these guys talk about. I urge your folks to watch this. Go to Dr. James Tour on YouTube and watch this series because I expose every one of these and I expose now the actual researchers' claims.
Yeah, and I mean, in the simplest terms, the chemistry acting on its own does not want to move in a life-friendly direction. And
Never.
So to get it to move in that direction, you need repeated interventions from intelligent chemists who pretend that they themselves played no role in this or that their interventions were, in a prebiotic environment, unnecessary. And yet the whole logic of what they are doing in performing simulation experiments is the uniformitarian logic of Charles Lyell, that the present is the key to the past. But if in the present they are actively intervening, they are not showing that undirected chemical processes would have been sufficient in the past. So there's a kind of deep problem. And you show so brilliantly in this lecture that we're going to embed in this video the multiple ways in which those interventions are accomplished by the chemists. Could you just say a little bit? There was you had quite a lot in the video about relay synthesis. Can you explain what that is and how that relates to this problem we've been talking about?
So relay synthesis is you take A and B and you mix it together. You want to make A coupled to B. Well, you get A coupled to B, but you get many, many different products along with that. You get A coupled to itself, you get AA, you get BB coupled to itself, you get ABA. So you get many different compounds. What the chemist does and what we do in our laboratory is you fish out the compound you want. Just say AB. You fish out that compound, you purify it, and when I say you fish it out, you use a lot of complex tools to be able to isolate that, and then you take that AB compound and you mix it in the next step. That is how synthesis is done. The way these guys do it, they'll make this mixture, and they'll say, well, we can identify it in there, but we can't isolate it because it's too messy. So what we'll do is we'll buy that AB.
It's too messy and not something that anything that would happen on a prebiotic earth without intelligent intervention. Yeah,
it's unusable, and they know
it.
And so
Yeah.
they buy it pure and they go on to the next step. So at
I
every
see.
step, they don't use the product that they've made. This is cheating at every step. You could never do this in a real synthesis. The early Earth could never do this, so they cheat at every step. They cheat at every step. And it's not just Steve Benner. If you look at the work of Lee Cronin, his lab is the most user input system. He has tubes and things piping in at exact times, and it's just so much information that is being put in there, and all he gets is junk. All the man gets is junk. He gets junk. He doesn't make the polypeptides that he says he makes, because when he uses real polypeptides that have active side chains, those interfere. And so you get different hookups. It doesn't work anymore. The chemistry doesn't work. And it's autocatalytic junk that he says that he uses these autocatalysis. He's making a bunch of rust that has nothing to do with life, by his own standards of what life is. And then he mixes a little bit of oil and water and he says, hey, those are like cells. They're not like cells. This is a Marangoni effect that has been around for a long time, has nothing to do with cellular life, and they make these bold claims that this is life. It is not life, even by his own standards of what life that he has talked about. And so it's all a game. It's all nonsense that these guys are putting out there, and I'm exposing this. Poor Dave Farina is a victim, where he listens to what these guys say and he just nods there. Oh, yeah. And Jim Tour doesn't know any of this. Yeah. And he doesn't know. He just doesn't know because he doesn't go to their papers. And so what I do on my video series is I actually take not just the title page of the paper and show the title that Dave Farina does. I actually open the paper. I open the paper and we go through it. We go through the experimental section and we see what these guys have done when they say that they've purified it. When Lee Cronin says that the more material, he keeps adding in more material. Well, how on early Earth do you just keep adding in more pure material? Well, even when he throws in more pure material, he says it cleans up the system. It doesn't clean up the system. It's only because he took out the ones that had polymerized and fallen out. He's taken off the supernatant. So 30% of the material he's taken off at each cycle. And he says, well, you see, it's self-purifying. It's not self-purifying. You purified it.
You did it. The
you did it.
supernatant
You
is
did
the...
it.
Yeah, what's the supernatant?
Supernatant is the part that's in solution on the top, and all the other things went to
It's
the
the waste
bottom.
product.
They came
it's
out.
essentially a chemical waste product of the reaction.
It's all his material keeps going,
Yeah.
and he says, you see, it's self-purifying. It's not self-purifying. You purified it at every step. And even then, it was just a mixture, because he himself, in that series that Dave Farina put out, that two-part series, he put Lee Cronin in there a lot. Lee Cronin even said when you do the foremost reaction, you get billions of compounds in seconds to hours. Billions of compounds. And here, Dave Farina says, oh no, you can use the foremost reaction would make these things. No, I've said all along, they make junk. They make absolute junk. And poor Dave Farina. Dave Farina says, Jim Tour says, calcium hydroxide would be relevant. It's really not relevant. But then he himself shows a synthesis of calcium hydroxide. Then he brings on an expert, Lee Cronin, he uses calcium hydroxide. He brings on an expert, Steve Benner, who uses calcium hydroxide. And Dave Farina doesn't even notice it. The guy doesn't even notice it. He doesn't understand chemistry. And the poor guy projects himself like he understands the chemistry. He does not. He does not understand chemistry, and he thinks in his own mind that he understands the papers, but he doesn't.
Yeah, and he's got a big megaphone, and I think that's why you feel that you've had to expose some of the hype and the false scientific claims that have been made.
And his listeners are not stupid, not at all. I mean, but they're not getting the true story. So all I'm doing is trying to show that there's a whole way that you look at this and then you see what's exposed here. They're not getting a true story on this.
I did want to, before we close today, just put this in, maybe, again, contextualize it a little bit with these experiments, because to explain the origin of life, as you were talking about our understanding of the characteristics of the cell, there are kind of multiple levels of problems that have to be addressed. The first is to build the monomers, the small constituents and the constitutive parts of the molecules, the amino acids and the proteins, or the sugars, the phosphates and the bases in the DNA, or the different parts of the sugar molecules and the lipids as well. But once you get those, that does not by itself a cell make. There's another layer of problem, and that is, especially with the DNA and the proteins, there's the sequence specificity of the constituent parts. That's what we mean by the information. It's because those nucleotide bases on DNA and RNA are functioning like alphabetic characters in a written language, or like digital characters in the machine code. This was the great insight of Francis Crick and his sequence hypothesis, that these are literally containing information or instructions for building other molecules, the DNA for building the proteins and so forth. But then that's the second level. But even if you get the information-rich DNA and proteins and there's specificity of arrangement involved in the lipids and sugars as well, we now know. But even if you get all those molecules with all the information they need, there's still an additional problem, which you discuss in your video about Steve Benner, and that's the 10 to the big number, 77 billion possible ways. Can you tell this huge number of combinations that are possible for the arrangement of just the protein-protein interactions? That's another, getting the right one of those possibilities is an additional problem as well. Can you tell us a little bit more about that?
Yeah, origin of life researchers never reflect on this. They don't want to go near it. So it turns out that there are other types of interactions. So of course we've been talking about the information interaction where molecules are hooked up to other molecules by a covalent attachment, by a chemical bond. There's other types where molecules are just non-attached by a chemical bond, but they're interacting. They're close enough to interact. And there are these arrangements. These are called the non-covalent interactions. Those are turning out to be exceedingly important because information flows through these packages through what are called electrostatic potentials. We've written papers on electrostatic potential interaction. And what happens is when you get this non-covalent interaction that goes down these, you have to have a proper arrangement. Well, how can these non-covalent interactions, there's so many different combinations, how do you get the right ones? Well, the number of ways that you can align these is astronomically high, exceedingly high numbers on the ways you can do this, and only a small number of those are going to work properly. The arrangements can be between protein-protein, between protein-DNA, between DNA-DNA, between amino acid peptide chains, polypeptides, and other polypeptides. So you have all of these interactions going on that have non-covalent interactions, again, between different carbohydrate strands or carbohydrates and proteins. How do these align? Nobody ever addresses those. So
is this what's meant by the so-called interactome problem?
Yes, this is the interactome problem. It's called the Leventhal 2.0 paradox. First Leventhal paradox was, how does a protein fold?
Right.
That's a big paradox. How do they fold without having other enzymes to act on them to help them to chaperone them into a fold? This is the 2.0, which is orders of magnitude, many orders of magnitude more difficult to think about how this could have happened. So you can't just take components and throw them into a lipid bilayer and expect them to ever work because you don't have this information. And what happens is when a cell is going to divide, it passes some of this information-rich material to each half, and then it clamps down on the middle and it keeps propagating this, and then this to the next cell and this to the next cell. So that's how the information propagates. It's not a random arrangement of these things. That's why if you ever take a cell and you dehydrate it such that you've even lost the waters of hydration between them to allow for this hydrogen bonding, then you can never bring the cell back to life because you've lost all of this non-covalent interaction of arrangement.
So it's a Humpty Dumpty problem as well.
It's a huge problem. It's a huge problem. Yeah. And so origin of life researchers don't even want to talk about this, and most of them don't even know about the interactome problem. Most of them don't even know about chiral-induced spin selectivity, which demands now that you had everything homochiral from the beginning. They want to avoid this. This is the problem, Steve. The target, what we're shooting at to make a cell, moves further away from us every year.
The more we understand about the complexity of the system the origin of which we're actually trying to explain.
Exactly.
The problem gets harder and harder and harder.
The cell is not getting more complex. Our understanding of it is getting more complex because 100 years ago we thought a cell just had a bunch of protoplasm in there. We had no idea of the complexity. And every year we're finding more complexity and we're like, wow, I got to deal with this problem too. I got to deal with this problem too. These guys who work in Origin of Life are absolutely clueless on all of these issues, and even on the issues that they think they have figured out, it doesn't work. And that's why when people like Lee Cronin say the primordial soup model is a good model, and then when I pin him down and say, where is the goodness to your model? How do small molecules get to big molecules that can then form a cell? He has no idea, so he starts agreeing with me. Yes, we're clueless on how this happened. All we know is there was no life, and then there was life, and what happened in between, we don't know. So he ends up agreeing with me when you push him enough. But then when he gets on the program again, he says, the primordial soup model is a good model. He has no idea. This thing doesn't work. It absolutely does not work.
It reminds me of some conversations I had when I was doing my PhD on origin of life biology in Cambridge. There were very famous labs there, the MRC lab, and people doing a lot of chemistry and molecular biology and biophysics and so forth. When they'd find out I was working on this, oftentimes they'd kind of take me aside and say, "That's fascinating." He said, "What's the status of this?" And I'd say, "Well, really, pretty much no one has any idea how life arose by undirected chemical processes." And people would say, I've always thought that myself. I haven't, what we get in the textbooks is so far removed from what seems like chemical reality. I've been deeply skeptical. But it would always be kind of in hushed tones, like no one wanted to admit that the emperor had no clothes. But you're doing a very good job, Jim, in exposing these deep and profound problems at the level first of building the constituent parts of those four classes of molecules, of the problems associated with getting the constituent parts arranged in the right way, and then the problem of getting the molecules to interact with each other in the right way. At every level, you have these specificity requirements that haven't been solved. One last question, and this is for some, I think, perhaps the most counterintuitive thing that you are known for saying about this, because people have long thought that if there was just enough time, we could build anything by chance or by some sort of undirected self-organizational process. There was a famous scientist in the 1950s, George Wald, who used to say that chance was the hero of the plot, that given enough time, the improbable would become possible, the possible would become inevitable, and voila, you would have life just because you had so many interactions. But you've actually reversed that and says time is not the hero of the plot. It's not even working in your favor. It's working against you. Can you explain that?
Yes, because organic molecules decompose. They decompose rather rapidly. Under the very conditions in which they form, they decompose. And we show this over and over again. Even Steve Benner shows it in his own work, that these things decompose under the very reaction conditions in which they form. Typically in a foremost reaction, ribose half-life, under the very conditions in which it was made, is 5 hours. That means you have half the amount of ribose that you had 5 hours before, just because of its decomposition under the very reaction conditions that it was made. So time is your enemy. That's why chemists who like to go home for the weekend and let their reactions just run always get bad yield. You have to watch that reaction, and you have to stop it as soon as the material that you want starts decreasing. You've hit the optimal, you hit the peak, you got to stop that reaction because it's going to decompose under the very reaction conditions in which it forms. And
then you have to intervene to scoop out what you want.
And poor Dave reads a paper, and the paper says time is on our side. The author was using that as a colloquial expression, just using that as an expression, meaning that you had a thermodynamic product rather than a kinetic product. And he thought that where she was saying time is on your side, he said, see, now Jim Tour's going to have to pay attention to this. The poor guy didn't even understand. He doesn't even understand a poetic expression when it's used in this paper versus what's really there. I mean, it's just so painful for me to listen to his interpretation of these papers. But I'm going to come out with all of this. So have your your viewers, keep an eye on Dr. James Tour. Go to that YouTube channel and subscribe, and you'll see when these things are coming out, because they're going to start coming out very soon, and it's going to be one after another that's going to expose all of this that I think is going to change the argument on origin of life.
Well, Jim, I think it already is changing the argument, and a lot of people at various conferences that I've talked to recently are aware that this debate's going on, and that you have been calling out the overhyping of these prebiotic simulation experiments. There is a huge disparity between what is told to the press and what is conveyed to students in textbooks and by popular YouTube bloggers and what the actual scientific evidence shows. And you've done a great job in exposing that disparity. And I think as a result of that, you've done a great service for science. And I know it is uncomfortable to have to take on someone who might not seem to be a worthy scientific interlocutor because he simply lacks the credentials and the expertise that you have. But it's necessary because some of those people operating in the internet environment have access to millions and millions of viewers, and they are conveying that very misinformation that you've been committed to exposing. So we commend you for that, and thank you for this really spirited interview. And we will be promoting the videos that you have coming out, including this first one, in which you address the claims of Steve Benner in this longer lecture that you've given. I think it was at Rice with a student
Correct.
group, and we'll be promoting that and hoping that doing our best to get the word out about what the real state of the science is. So thanks very much for a good interview, and we'll do this again and talk about your next series of videos about the work of Lee Cronin. And then I think there's also some videos that you've done about how Professor Dave and others have misused the work of one of your former colleagues, Bruce Lipschitz, I think.
Yes, it was terrible what Dave Farina did to him, how Dave Farina portrayed his work.
Yeah, so
Really,
we're going to sort
really
all that out, but this video will be promoting your lecture on the work of Steve Benner and the whole controversy about building RNA molecules, and we'll call it good for today. Thanks very much.
Thank you.